Okay, second review for final should help with quiz 2. First two we are doing derivatives. Notice the ln. Now, how I remember ln, so the derivative of ln, I'm going to write a u because it doesn't matter what that is du over u. So what does that mean? You keep it whatever it is that goes in the denominator, derivative of whatever it is goes in the numerator. And with some examples, it'll look great. If we just have an x, then it's just 1 over x. So, as we'll see in this first example. Okay, this looks like quotient rule, but really this is just a divide 2, which is a 1/2. Right, so before we do anything, I'm going to rewrite that. I like it like that. Okay, now the 1/2 we can leave. I tend to just write it as part of f. Okay, f is 1/2 x squared, f prime, bring down the 2 and subtract 1, so 2 times a half is 1, so we just get x. G is ln x, and like I was saying, derivative of any ln is a derivative of that, well, derivative of x1, over itself, over x. So derivative of ln x, 1 over x. In the next example, we'll look, well, what if it's not just an x, right? But for now, there it is. So derivative, y prime, f prime g, x times ln x, plus fg prime, so 1/2 x squared, multiplied by 1 over x. Let's simplify this, x ln x. One of these x's can cancel, so we just get a 1/2 x. You know, I say that answer's fine, but there are times we need to set equal to 0 and solve, so we could factor out this x, but that's really about it. Like I said, this answer is acceptable, or x ln x plus 1/2. Okay, natural log, hopefully you find is the second easiest derivative, e to the x being the easiest in my opinion. Alright, next example, this one looks worse, like, oh man, product rule, chain rule, whatever. Well, technically we are doing chain rule, but using this formula, that du, that is the chain rule. That's where that comes from. Kind of like the EU, du, really that's chain rule. So, this is almost a one-step problem. The denominator, you leave whatever u is. Whatever you're taking natural log of, that's a denominator. Numerator, derivative of that. Well, that's 12x to the third minus 2x. And then simplify if possible. Sometimes you can't. This one, all it looks like I could really do is factor out an x, right? And cancel 1x. So you can either at this step just cancel an x out of each term. The numerator does have a 2 in common, but the denominator doesn't. Well, I'll do it the right way. Let's factor. Factor out a 2x, we're left with 6x squared minus 1. Factor out an x, we're left with 3x to the third minus x. I guess we could have factored out an x squared. Let's go ahead and do that. Okay, x squared in the denominator, we have 3x squared minus 1. Doesn't change a whole lot, but I guess it looks a little cleaner. Okay, cancel an x. That's all we could do. Here's your derivative. We have a 2, 6x squared minus 1. We have an x, 3x squared minus 1. Alrighty. Moving on, equation of a tangent line. So, you know, I know there's a fancy way of writing it with derivative. I don't want to memorize too much, so y minus y1 equals mx minus x1, back from algebra. And just know m is your derivative, right? And x1, y1 is your point. Well, they gave us our x. X is 0. So there's x1. We don't know y. We can just substitute it in to get y, right? Let's go ahead and do that first. So our y, or y1, whatever you want to call it, that means we're going to substitute 0. So I'm going to write function notation. Y of 0 equals, so we have ln, and then 0 squared Not that I need to write that, but just showing you we are in fact substituting 0. So we just get ln e, and these are inverses of each other. Ln e is 1. So therefore we know our point. We know our x1, y1. It's 0, 1. Okay, now we need derivative. So y prime, well, we have an ln, so du over u. Du is just 2x because e is a constant, right? It's kind of like pi. It's some number. It's 2.7 something. Derivative of a constant 0. So we have 2x over x squared plus e. Now, I know my x value is 0, so let's go ahead and plug that in. You can almost see it right in our head, but we get 0, right? 2 times 0 over 0 squared plus e. 0 over e, anything 0 divided by anything, well, except 0 is 0. So our slope, right, our derivative at 0 is 0, which is our slope. So it's going to be an interesting equation, but y minus y1, which we got 1, okay, equals m0 x minus 0 as well. Right? X was 0, x1 is 0. So the entire right side, 0 times anything is 0, but distribute it, whatever. We get y minus 1 equals 0, or just y equals 1. Okay, that's our equation of our tangent line. It comes out horizontal, not that it asks, but there we go. Next example, we have a word problem. I didn't write the whole thing out because I think this is enough. We have some function for revenue. We have some function for cost. We want to maximize profit. We've seen this function really since, I don't know, first or second week. So we take our revenue minus our cost. Now, sometimes the revenue, they don't give us the actual function. They give us a p, a demand function, and we'd have to do x times p. But in this case, it gives us the entire function. So let's substitute it in. Profit is our revenue, 300 ln x plus 1, minus our cost, which is given at 2x. To maximize, we do derivative, set it equal to 0. So derivative, p prime. 300 is constant, it stays, multiplied by the derivative of this, so denominator, x plus 1, numerator, 1. Right? Derivative of x plus 1 is 1. Now derivative of negative 2x minus 2. Set it equal to 0. So we have 300 over x plus 1 minus 2. Let's add the 2 to the other side. Clear a fraction, multiply by x plus 1. I think we could do that in our head. We'd have 2x plus 2. Right, we're doing this. Okay, equals 300. Subtract 2, 2x equals 298. Divide 2, x is 149. Now, we need to verify this is in fact a max. So, let's go, well, here's our derivative, right here. So we could do second derivative test or do test points, up to you. I don't know. I oftentimes when I see a fraction just do test points. The last video we did a lot of that though, so I guess we'll do second derivative. So I'm going to rewrite that though. Let's rewrite it as 300 x plus 1 to the negative 1, right? Because that just brings it to the denominator, negative 1 power. The reason I choose to do that is I don't have to do quotient rule or anything now, right? I do have chain rule because it is in parentheses. Even looking at that, chain rule is sweet because it's just 1, right? So, derivative bring down the negative, oops, equals negative 300, x plus 1 to the negative 2. Chain rule is just times by 1. Derivative of negative 2 is 0. Now, we don't really care about this much because I could see it's going to be negative, right? Because negative 300 over x plus 1 squared. If we plugged in 149, it doesn't really matter. We get positive here, we get negative here. Negative divided by a positive is negative. So if the second derivative is negative, then we know it's concave down, which means it was a max, which is exactly what we hoped for. So x is 149. That means 149 units should be produced and sold, right? X is the number of units. So when 149 units are sold, profit is maximized. Alrighty. A couple more natural log problems. These are both just derivatives and they look horrendous. Great news, natural log has a lot of properties that make things easy. One property says if we multiply, so I have natural log of a product, and we'll just say a times b, we could do the natural log of each, but add. Okay, that's one property. We're going to use that one. Likewise, if it were divide a over b, all that does is change this to a subtract. Okay, if we had a divide. Second property, it says if I have natural log of some number a, we'll just say to the x, I could bring that exponent down and do x times ln a. Once you get the hang of these, really it can be done in one step. I have one natural log with a bunch of things that are being multiplied and raised to exponents. So before we differentiate, because remember ln du over u, but doing the derivative of all that would be horrible. So let's rewrite it. I could see the exponent 2. I'm just going to bring that down now. And I'll explain here in a second. 3 ln 2 plus x plus 4 ln 3 plus x. All right, why does this work? Well, I used property 1 to get these all, right, separate natural logs with a plus. Separate natural log with a plus because it was all multiply. Then I brought that exponent, that 2 down all in one step. Right? I brought that 3 down. I brought that 4 down. Now why would we do this? Because now doing the derivative, when it's all plus, I could just do derivative of each piece. Okay, each term. So let's do derivative. Well, 2 is constant, it stays. Derivative ln 1 plus x, derivative of 1 plus x is 1, over itself, du over u, right, plus 3 du over u, again we get a 1, 2 plus x, and du over u, we get a 1, 3 plus x. And that's it. If we had a set equal to 0, we'd have to find a common denominator, do a lot more work, but for the derivative, you know, the only thing I would do is 2 times 1. This answer is perfectly fine. Okay? Looked horrendous, right? And really, I needed this step. Probably could have skipped this step with some practice. 2 steps. Derivative of all that natural log. Okay, those are great. Okay, properties of natural log makes things quite easy. Last example, however, it is not one natural log with a bunch of multiply, right? It's natural log of this multiplied by another natural log of this. There is no property to combine 2 natural logs that I'm aware of, easily at least, to do this. So this requires product rule. This is some function f, this is some function g. and they're multiplied, product rule. F is ln 3x plus 1, f prime. Here's the good news. Derivative is easy, right? Derivative of the inner function is 3 over 3x plus 1. G, ln 5x plus 1. G prime. Derivative of the inner function, 5 over 5x plus 1. So the derivative, using product rule, f prime g, 3 over 3x plus 1 times ln 5x plus 1 plus fg prime ln 3x plus 1 times 5 over 5x plus 1. Honestly, nothing to do here really, right? I mean, I could get LCDs, but it's not going to get any prettier. The only thing I prefer to do is combine these, like, right, that kind of looks weird, so I would just do this. 3 ln 5x plus 1 over, oops, that's right, over 3x plus 1 plus 5 ln 3x plus 1 over 5x plus 1. Done.